Hi everyone, I hope you're well, and I hope your families are well. After the Lab 8 review video this morning, it dawned on me, I have visitors in my house. You! So I run around and cleaned. Yes, a bizarre sense of humor follows me here. Okay, this is the Lab 9 introduction video. There will be a separate video for Lab 9 itself. Excuse me, I still have this cough. And remember, since Lab 9 builds on Lab 8, take a look at the Lab 8 review video. Okay, here's a reading. The quiz is optional. I just changed the due date to line up with the with the change in our schedule. This visualization and the Monte Hall problem video come into play with the lab introduction. So I'll point those out at the time. When you start in the lab, if you have questions, you can post them to this discussion so that everyone can see responses. If that doesn't work, remember, I can take a look at your no machine session with you. So let's see how much we can do with the discussion and take it from there. Okay, lab 9. In this lab, we're learning more about probabilities. So we'll see there are prior probabilities and conditional or posterior probabilities. And we have one more lab with function parameters coming up. It's an important concept. Okay, prior probability is a probability where you don't have other information to help you compute the probability. So imagine I show you a coin and I ask you, what's the probability if I flip it that it lands heads? You think for a minute and say, okay, there are two possibilities here. Right, so 2 is in the denominator. And the numerator will be 1 because that's the number of ways they can come up heads, right? It's either heads or tails. A conditional probability is different in that you know something specific about the situation. Okay, suppose I show you the coin again and tell you, I just flipped it 100 times and it came up tails 100 times. Now, what would you say the probability of it landing heads is? Okay. We have a series of Socratic questions. I'll bring the question up. If there are any comments, I'll make them and pause for a second. What I'd like you to do is to hit pause, think about the answer, and then hit resume again. Well, I'll give the answer and explain it. Okay, I'm going to skip over this right now until we get to that first question with this visualization. All right, question 1. You have an opportunity to win a car or a goat. Not that there's anything wrong with goats. I know some people might prefer goats to cars. So let's make a deal. 3 doors were shown. One was a car, the other's goats. The contestant got to pick a door, and then Monte Hall would open one of the other doors showing a goat. But then the question here is, you're given the choice to change to the third door. Should you or shouldn't you? I'll pause here. The answer is you should. And go back to Canvas and watch the video. It does a better job explaining why you should switch doors than I can here. Okay, now the falling balls. Let me show you the visualization. Right. And there's a link to this. You can go to it and watch it yourself. So this window here is, let's say, 100 balls wide. You can see balls are dropping. They strike a shelf. They strike a shelf. See, they continue to fall through. The shelves are 20 balls wide, and they overlap by 10 balls. Okay, so what's the probability that a ball strikes the red shelf? I'll pause. Okay, the answer is C, 2/10 or 20/100ths. Remember, this window is 100 balls wide. This is 20 balls wide. So we have 20 in the numerator, 100 in the denominator. Okay, next question. What's the prior probability that a ball strikes the blue shelf? Don't forget that the balls that strike the red shelf fall through. I'll pause. Okay, so for the same reason as the previous question, the answer is C, 2/10, because we're considering for our denominator all 100 balls. In the numerator, the 20 of those balls that strike the blue shelf. Okay. Now I have a conditional probability question. What's the conditional probability that a ball strikes the blue shelf given that it has struck the red shelf? All right, think about that. Okay. Imagine 20 balls striking the red shelf. How many of them also strike the blue shelf? Well, that'll be 10. So the answer is 10 divided by 20, D, 1/2. So remember, 20 balls strike the red shelf. Of those 20 balls, 10 strike the blue shelf. Okay, question 5. So this time, the probability that the ball strikes the blue shelf, given that it's missed the red shelf. Okay, I'll pause. All right, how many balls missed the red shelf? 80 of them, right? Since this is 20 wide, the number of balls over here and the number of balls over here has to be 80. Of those 80 balls, how many of them strike the blue shelf? That would be the 10 balls right up here. So the answer here is B, 1/8. Okay. Well, think about this for a second. Do we have information here? If we do, it would be a conditional probability. Otherwise, it's just a prior probability. So I'll pause, think about it. This is B. This is a conditional probability, as we'll see in a second. What is the evidence here that makes this a conditional probability? Think about it. I'll pause. The answer here is C. If the woman's in the 38th week of her pregnancy, she couldn't have possibly given birth earlier. So this makes this situation different than the example prior probability that I did in the Lab 8 review. In that one, we had no information akin to this. Okay, that completes the lab introduction. I'm going to go do some more cleaning now.